Let's have a look at Doppler moving listener. This is different. Now you may have thought when you did that moving source one that you found the higher frequency because the source moved towards the listener. All right. That when the listener moves towards the source with the same speed, that we're going to get the same increase in frequency because of the decrease in wavelength. But it doesn't work that way. It is not strictly relative, and we'll see why. We'll call this again source. We'll call this a listener. This time this guy is putting out waves. This time the listener has the velocity. Call it VL if you like, and the source is stationary. Now let's just compare the two situations. Before, what you had was you had these waves being put out by a moving source, and basically during the time it took the wave to travel this far, the velocity of the source would subtract a bit. But this situation is different. This time you've got a wave, if you like, from here moving towards the listener, and the listener, if he'd stayed still, would have met the wave here, but he's going to move a certain distance. Now the period for that is not going to be the same, because in this case we use the normal period. In this case we don't do that. The period for the wave to move from here to here is normal, but the period for the wave to move from here to here is smaller. So we can't have that just that symmetry, that relativity of it. Now it would be different if we were looking with light, because light's got that whole relativistic thing going on, where the speed for the observer and for the source is the same and things like that. So but anyway, it's a bit more complicated. So let's just stick with this one at the moment. So what are we looking at? What we're basically saying is that the listener is going to meet the wave. The wavelength isn't really any smaller. It's an apparent change in wavelength. Whereas with the moving source, it really was smaller. If we could stop time, we'd see it smaller. Whereas if we could stop time with the moving listener, it would still be the same. It's just that the listener's moving up and meeting the crests earlier. All right, and thus he has an apparent change in wavelength and so an apparent change in frequency. All right, whereas there was a real change in wavelength with the other one and an apparent change in frequency. So we know that this would be VWT, right? And we know that this here will be VWT dash, the new period. And we know that this will be V listener T dash, V listener T dash. And we know that those two added together will be equal to VWT, which is the wavelength. What are we actually looking for here though? We are looking for the new frequency, right? F dash. So let's just see if we can simplify this a little bit. We've got T dash VW plus VL, right? We had here VWT, that's that wavelength. VWT is the same as VW over F. So let's just get rid of that, and we could put the frequency there, right? And we could say that the T dash comes down here. So we've said that VW over T dash, okay, is equal to F times those two guys multiplied. Now VW over T dash is the same as FW let's just have a little think here. VW, we're nearly there. I feel we're nearly there. Let's just bring the VW down here, and we've got 1 over T dash, right? Now 1 over T dash is equal to F dash. There we go. So what we've got is that F dash, the new frequency, is equal to VW plus VL listener all over VW times the old frequency. So very similar formula to the moving source. Again, what I say to you with these type of issues is look at your signs. This was all based on source having a was stationary, so it didn't even have a frequency. The waves we could have said were positive. I wanted to add that So again, just make sure you get your signs right. If we call that a negative velocity and we wanted to add it, then we'd have to ignore that and maybe make that a negative. So just have a look at the signs and make sure it all works. We want to add these two velocities. So if we called that velocity a positive, we'd have to call that one a negative to get them to add. So, but you know what it needs to do. When the listener is going towards the wave, then we need to have a higher frequency. So this on the top needs to end up being bigger, because that will then multiply the original frequency and get a higher frequency. So have a look. If you define it right from the start, you'll be okay. But have a look and use some common sense.